Good morning, everyone. Today we will see the topic recurrence relations. This is an important topic in design analysis of algorithm to check the correctness of algorithm. So first we will see what is recursion. Recursion is the concept where the function is called repeatedly. Uh, there's a function at your module that same function called itself is called recursion. It is a self-referential approach, allows complex problems to be broken into smaller subproblems and making them easier to understand and solve. Uh, Recursion involves two key components. First one, base case and recursive case. Here, recursion means calling the same function many times, calling itself. The function calls itself is called recursion. So, when the function should be called, when the function should be terminated. So, base case refers that when the function should be recursive call, function should be terminated. And it's a condition. We are giving condition in the base case. When the condition occurs or meet, the function will be terminated. And recursive case, when the recursive call will continue, there's a condition. If the condition met, that function will be called itself. It calls itself till recursive case becomes base case. So recursive case is the condition where the function calls itself. And the base case is a condition where the recursive function will be terminated. That is called base case. And we will see the structure of recursive call. So there's a main function. Within the main function, there is a function called recurse. Here, the recurse is a function call statement. It calls the function recurse. So within the recurse, there's a function called recurse. So the function calls itself. The function name and the function call both are same. So that means the function calls itself. So when the recursive case are satisfied, the function calls itself. If the base case is satisfied, the termination of recursive function will be happen. And we'll see an example, factorial of n. So function is the function name is factorial, n is the parameter to be passed to the recursive function. Initially, there is a base case. All recursive function has base case as a first statement. If n equal to 0, if n value equal to 0, return 1. When the function executes return 1, the control will be terminated. The recursive function will be terminated. So now initially the value of n will not be 0 most of the case. At that case, it will go to the else part. Else, return n into factorial of n minus 1. So 5 into again is the factorial of n minus 1 is a function call. It calls itself. The function calls itself. So again, the function will be called, that will be repeated till n value becomes 1. For example, n value is 5. For first call, n value is 5. Next call, 5 minus 1, 4, 3, 2, 1. If n value becomes 0, the base case will be satisfied. The function will be terminated. That is called recursive call. So recursive call occurs when a function calls itself. Uh, and it's a key principle for the function in a computer science. That's how we can solve the recursive algorithms. Where we can use recursive functions, where we can use call, that will be important in algorithm analysis to check the correctness of algorithm. Recursive calls are made and resolved step by step. Each function call suspends until the base case is reached, after which the stack unwinds and computes the result. So for every function call, all the information are stored in a data section called stack. Once it reaches the base case, again it rewinds it. It substitutes the value of the current to the previous till we get the final result. That is the use of recursive call. And a recursive function is a pseudocode for calculating factorial of number using recursion. So function is a keyword. Function name is factorial and n is a parameter. Base case. is n is 0. If n is 0, return 1. The function recursive call will be terminated. Yes. Return n into factorial of n minus 1. So factorial again is a recursive call. It calls the function itself. Factorial of n minus 1. So this function call is repeated till n value becomes 0. And base case, if n is 0, the factorial is 1. Recursive case, for n is greater than 1, the factorial is calculated as n into factorial of n minus 1. And recursive call, calculate factorial of 4. Initial call, factorial of 4. Check base case if n is not equal to 0 and n is not equal to 1. So initially the base case is not satisfied. So it will go to the recursive case, where recursive case is factorial of 4 equal to 4 into factorial of 3. And again, factorial of 3 is the input. Again, base case is false. It will go to the recursive case. So this process is repeated till n value becomes 1 or 0, the whatever we can write. So to return 1. So when the algorithm executes return 1, recursive call will be terminated. And we can use the data structures called call stack. Is the data structures used by computer programs to keep track of function calls, how the function is executed, what's the parameter of the function. All the informations are stored in a stack. And when the recursive call is happen, all informations are stored in a new frame in the stack. The frame contains information about the current function call. And when the function completes its execution, the frame is removed from the call stack and the program returns to the previous frame. So example is the initial call. There's a frame that will be filled from bottom to the top. So it follows the property of last in first out. For example, we are going to find 4 factorial, and initially 4 into factorial of 3 is the first recursive call. Again, next 3 into factorial of 2. For each recursive call, there is a new frame is created in a stack and information is stored. And finally, when it reaches the base case, the value is factorial of one value is 1, and that value will be substituted in the next recursive call function, and that will be so recursive that will be the unbind the new frames. Finally get the result, that is 24. And unwinding recursive call using stack. So factorial of 1 value is substituted in factorial of 2, 2 is substituted in factorial of 3, 3 is substituted in factorial of 4. This is called unbind. So all the informations are stored in a stack. Using the stack, the function value will be calculated. And what's the recurrence relation? So it shows the relationship, how the recursive algorithm is executed. There is a mathematical equation defines a sequence of terms where each term is expressed in terms of one or more previous terms. So n minus 1 derived from n minus 2 derived from n minus 1. So current term is derived from the previous term. So general form of recurrence equation is the sequence of term an. An is equal to f. F represents the function of an minus 1, an minus 2, n minus k, comma, till n. So where an is the nth term in the sequence. An minus 1, minus 2, n minus k are earlier terms to a of n. So what is the f? F is a function defining the relations. So k is the order of the recurrence equation. So nth order, n minus 1 order, n minus 2 order. So how the position of the term in the sequence is called the order of recurrence equations. So when we want to analyze the recursive algorithm, we have to derive the recurrence equation, and we are going to study about the property of recurrence equations. Then we can find the time complexity or the effectiveness of the proposed algorithm. Some examples for recurrence equations are Fibonacci series. Normally, Fibonacci series is starts with 0 and 1. It's initially 0 and 1, and the third term is calculated as sum of previous two values. That is nth term is sum of n minus 1 and the n minus 2 terms. The current every term in the sequence depends on the previous terms. And so how we can write the recurrence relation for Fibonacci series? So f of n is equal to f of n minus 1 plus f of n minus 2. And factorial, how to find n factorial? So n factorial equal to n into n minus 1 factorial, where n is greater than or equal to 1, where 0 factorial is equal to 1. And a tower of Hanoi. So T of n is equal to T of n minus 1 plus 1. So for every recursive call, there is one movement. That is one represents number of movement in tower of Hanoi problem. That is T of n is T of n minus 1 plus 1. This is a recurrence equation. So when we find the time complexity of recursive algorithm, first you have to derive the recurrence equation, and we are doing analysis of recurrence equation to find the time complexity or effectiveness of algorithms. Thank you.